All right, so in this video, we're going to be going over how to basically complete the whole hub and spoke network creation that we've been doing in the previous videos. So if you haven't caught the other videos, basically what we're creating is a hub and spoke network in Azure. And what this allows you to do is have a centralized hub VNet that you can then store, all your resources in, any type of shared resources, um, security, virtual network appliances, things like that. Things that you kind of want to have at a central point to be able to manage a lot easier. As far as what our current setup, we have two spoke networks. So we got a hub. And we're doing this all in Terraform here. So we got our hub.tf, which contains our virtual machine, the VNet, and the subnet that sits in the hub network, and then our test spoke um, VNet, and then the hub. So what we're going to be doing in this video is essentially setting up a way for the communication to transverse the hub VNet to talk amongst the different networks. Because when you create this type of setup and you have peering connections between both spokes to the hub, the spoke networks may share resources that one may need to access, and the hub doesn't have the ability to do transitive routing. So you have to have some type of device that sits in there to allow this to happen. So we're going to set up an Azure Firewall to do this. It doesn't have to be an Azure Firewall. It can be Cisco Firewall. It could be another router, Palo Alto, whatever your network appliance of choice is. So to do this in Terraform here, I'm going to actually make a new file, call it firewall.tf. I'm going to grab the code for that on Terraform's website here. So under providers, Azure, under the documentation, you can usually just search for firewall and it should come up under resources here. So only thing we need is we're going to put it, we already have resource group, we have virtual network, subnet. So we will need to create a new subnet because we need a subnet that references this Azure Firewall subnet name, and then we'll need an outside IP address, and then obviously we'll create the resource there. So let me just copy all of this here, and we're going to make a couple changes. So I'm going to paste that into this file, and what we're going to change is, let me see. So virtual network. So the subnet is going to live in the hub network. So we're going to use Azure RM Virtual Network Hub Network for the virtual network name. For the resource group, it's just going to, I think I have it in here. It's just going to be .main. So this is going to be where all our resources currently live. So let's go in here. So main.name there. And then for the address prefixes for this subnet, we're going to want it to live within this hub VNet. And we can see we already have a subnet that's using 10.2.1.0/24. So we're just going to go ahead and just do 2.2. That way that sits in between the hub VNet network. Then we're just going to create a simple public IP address, just a standard one. Let me change these to main as well. And when you see like resources, if you're using like VS Code and you notice it's like white instead of like blue, then sometimes, depending on what you're doing, it may not be correctly formatted. But that's not always the case. Here, same thing, just throw that in the main. And I think that's it. So the subnet ID is going to be example. Yeah, we'll just leave those as example. So basically it's referencing this Azure RM subnet example.id. As long as that name is example in your configuration, you should be good. So then we're going to save that, and then we're going to run this. So I usually do a Terraform plan just to make sure that there's no errors or nothing's going to get destroyed. And then once that just shows that there's things being added, which here it's probably going to show everything because I usually destroy this after each day that I'm running this. That way you don't incur that much of a cost in your Azure spend. So we got 21 things to add, so that's good. So I'm just going to do a terraform apply, and I'm just going to do an auto approve. That way I don't have to auto say yes at the end there. So I'm going to let this run. It's going to take a little bit here, and then we'll go in and configure some of the firewall settings, route tables, and things like that. Do some other tests. So we got all of our resources deployed now. So now we're just going to need to do some configuration within Azure itself. So we can do all of it in Terraform, but I'm going to kind of leave some of that to you to kind of figure out as I'm doing it through the portal how you can do it in Terraform. And I guess you could say I just kind of want to not do it all in Terraform in the video to kind of speed things up, just to kind of show you how it's done through there. But then I'll also show you a way you can import some of your configuration back into Terraform as well later on in the video. So now if we go back into their portal, I'm going to go to my resource groups, and I have everything deployed in one group here. So as you can see, we got 3 virtual networks, 3 virtual machines, 2 IP addresses. And the reason for those is because I had a Bastion host that I was set up to actually remote desktop into these VMs, but I didn't want to. It takes a while to provision, so I kind of left that out of my code. And then I got these NICs for the VMs and our firewall and then the disks, obviously. So what we're going to need to create is 2 route tables, because we're going to need route tables to define how to get to each other's network. And we're going to push everything up to the hub VNet here. If I could find it. Yeah, hub VNet right here. So what I'm going to do is, and actually before we do that, let's go ahead and test that we can't get to the other side yet here. I'm going to go to the test VM. I'm going to go to networking. And then I'm going to take the public IP address. It's not showing it. Give me 1 second here. Let's go back. Let's actually make sure that well, let's go to the dev one. Maybe I didn't attach it to the test. Okay, so yeah, we can take this one. So we'll just do our testing from this VM here. So we don't have a network security group put on it, so we're going to be able to get directly into it here without any type of rules. So if we go back into my code here, I think I put the password should be here. Take this password, copy that, and then remote directly into it. So what we're going to do is we're going to test seeing if we can remote desktop into the other VM directly from this network. And we shouldn't be able to. I could test with ping, but ping's not turned on the other host, so it's going to fail anyway. So sometimes ping's not really a good troubleshooting method since it's typically turned off in most networks. But I'm going to pull up remote desktop here. And let's see here. And we're going to need to find the IP address of the test VM, which we should be able to see. And it's probably grabbed one of the first available ones. So if I go to the test VM, we should see that it's 10.1.1.4. So we go 10.1.1.4. We're not getting any connection. So once we get that set up, we'll test that again here. So we're going to create 2 route tables. So we can actually go route tables here and just create 2 of them here. So region, we're going to put it in the same region our resources is in, and we're going to call this here, call this hub, or no, it's going to call it dev route table. So propagate routes, that's if you have like a, basically, if you have some type of network device on-prem, or I mean a network on-prem, you want to propagate those routes into this route table so it knows how to get to those. You can do that. If you don't, you could do it, say no, and then you just have to put those routes in manually. So I'm going to hit create route table, and then we're going to create another one here. So let's look for route tables again while that's deploying. And this is going to be called test RTB. Oh, I don't even think I changed. Hold on. I missed a whole bunch of steps there. Resource group, East, US. And then not going to worry about any tags or anything like that. So we don't need a route table for the hub VNet because that's going to have the firewall. So we'll do the routing between, like saying, if source is this, destination will be this, and vice versa. Then we'll do some destination NAT type stuff as well. So if I go to the resources, we should see our route table in here. Okay, so here's one. Now there's a little bug that I've caught when trying to actually tie these to subnets. So if you go to associate, I notice sometimes, oh well, now it shows it. Sometimes it won't even show like this drop down. You actually have to go on the subnet and choose this route table as the route table that you want. So dev subnet, then I'll hit OK. So now we'll go back to, should be able to just go to route tables and test, subnets, associate, and what's this, test, so test, and then test subnet. So now that those are set up there, we are going to then say we're going to create some routes. So in this test route table, we're going to say, we're going to hit add here, and then call it route to dev VNet. So the source, IP address, destination range is going to be 10 dot, I think it's 0 actually. Let me look. I think our dev, what subnet are we using? 10.0.0/16. So I'm just going to do the full CIDR range. In your network, you might actually, skinny that down, but for testing purposes, just going to make it a lot easier. Then the next hop's going to be the virtual appliance, and I need to grab that, which is, I believe it's 10.2.2.4. It probably is because what Azure does is they reserve 3 IPs. So the first one, then the next 2. They reserve 2, or there's a couple that they reserve. So you kind of lose out on obviously your network, the first available, the broadcast, and then I think there's like 2 or so that they hold. 3 actually. So I think the next available one should be 10.2.2.4. And we can confirm that too here. So to find that, we'll go back home. And we're just going to look for our firewall here. So inside the test, okay, so yeah, 10.2.2.4. So now we need to do that on the other route table as well. So on the dev route table, we're going to do a route that says route to test VNet. And then the destination is going to be 10.1. Let me double check so I don't put the wrong thing in. I believe it's 10.1.0, yes. /16. So anything in that 10.1.255 or .0.0 all the way up to 255.255 range for the destination. Virtual appliance, which is our firewall, and again 10.2.2.4. So now that we got those set up, that still doesn't give us the ability to send out anything to that network because the firewall is not set up, and we can confirm that by going here and trying to connect again. So there's nothing saying how to get back and forth between each other. So what I can do now is go back to the firewall, and we'll need to create a policy to define that. So we're going to go to rules, and we're going to create a network rule collection, and we're going to hit add network rule collection. So this is going to be, let's call it allow VNet communication. And this is a collection of rules that you can set for, this allow action. And we'll just put this as 100. So the priority is top-down approach. So if you have anything above, I think actually 100 might be the default. Yeah, so it's 100. So 100 is actually first. So you might even want to do like say 200 because say there might be some type of deny you might want to put above that 200. And if you're at 100, you have to do some deletions and modifications that could, bring the network down for that short period of time. So I'm going to do route to test IP address, so protocol any source is going to be 10 dot. Let's make sure what's the test one. So test, so it's 10.0/16. Destination is going to be 10.1.0.0/16, and destination ports is going to be, we're just going to say asterisk for anything. And then this is going to be route to dev IP address any protocol, and it's going to be 10. So this is the reverse 10.1.0.0/16, and destination. And you could do asterisks and stuff there, but just to kind of show you how this would typically be done. It's going to be 10.0.0.0/16, and then again, asterisk for destination ports. And then we're going to hit add on this. So that's going to take a little second there. So now that we got that set up, we now have that back and forth communication. So we got our two spoke networks peered with a peering connection between the hub. So those can already talk to the hub network. Now we want to say, hey, I want to communicate with this virtual machine on the private IP going through the Azure Firewall. So you can see it's still updating the firewall here. So let's give that a second. So now we can see that both of our rules are in here, and you can see how this collection of rules can kind of allow you to kind of combine aspects of, allow and denies together if they kind of correlate with the, the environment or rule sets that or applications that you're trying to communicate with. So this is still going. So once this finishes, and then what we're going to do next then is we're going to force all internet traffic from the VM out through the firewall. So right now it's actually going out based off this IP address, but we're going to want it to go out based off of, pull it up here, this IP address here, test pip, which is a IP address that was 10.232.22.91. And you can verify that by going to, if I turn off the enhanced security configuration. And then we go into the Internet Explorer on the server. We could just go to Google. So google.com. And then just type in what is my IP. It may not show you there, but we could just go to what site? Showmyip.com. You can see it's 10.20.22.28.189.129. So now let's see if the firewall is updated. So it looks like it successfully updated. So now if we go back into here, open up our remote desktop session, and go 10.1.1.4. And as you can see, we can now get to it. So if I do an admin, user, and then the password, I believe I kept it the same across the, let's see what it is here. 10.1.1.4. Then paste that in there. And you can see test VM. So now we got that communication going across, and you can see 10.1.1.4 is available to gain access to. So I'm going to go ahead and just close out of that because we can see that that communication is working. So now what we're going to want to do is set it to where all internet traffic for this particular VNet, so basically for both of them, will actually go through the firewall. And the reasons for that is you may not want it to go directly out the Microsoft network because maybe you want to control the type of traffic coming in and out for like TLS inspection, any type of web filtering, any type of proxies, or application firewall level stuff that you'll want to monitor. So if I go into the firewall, I can actually, well, let's do it on the route tables first. So I'm going to show you what happens when we change this. So we go to the test route table, and we're going to create another route. And we're going to say internet bound. And we're going to say, I wonder if you can do a service tag for internet. Okay, no. So we'll just do 0.0.0.0/0. Next hop is going to be virtual appliance. And then it's going to be 10.2.2.4. And what you'll see is, so that's the test route table. Which one am I on actually here? This is dev. So when I do it on dev, it's actually going to kill the connection. It might take a little second, but come into routes. Let's go add a route and internet bound. The name doesn't matter. I'm just calling it whatever. So this 0.0.0.0 is basically a way to say, anything, that's not a part of any of these other more specific routes, send to this particular destination, which is our virtual appliance. So 10.2.2.4. So now that that's getting added, it might take a little bit of time to get into the route table, and we can usually see effective routes. So these are routes that are actually being propagated down to the subnets here. So here you can see internet. This is none because it's local. Let's see, but we do have a more specific one that's for virtual network. Let's see, nothing else here. This is all probably some Azure related stuff. Then you see we got a user defined route here that says, anything going 10.1.0.0.16, virtual appliance 10.2.2.4, route to test VNet, which is the name there. So let's do another refresh. And we might actually see our connection drop out. Yeah, see. Okay. So now as you see, I can't control this because it doesn't know how to get out to the internet, because on the firewall now, we need to go back and actually say, hey, if you're coming from any of the other networks, send it out to the internet. So we're going to go back to rules, the network rule collection, and we're going to add another one. Well, actually, you know what? We don't need to add another one. We'll go in here and add one. So we'll call this route to internet, any IP address, and we'll say source any, destination any, destination ports any. And so now that is going to, we're going to hit save. And then the other thing we'll need to do now is we'll need to set up a NAT rule to basically get back into that IP, that server, because we're not going to be able to access it again off of the IP address that was attached to the server there. So we're going to cancel out of this. Basically, our new IP, the way we're going to access it is this. Let's grab this here. Copy that, and we're going to go back to the test firewall. I'm going to go into the rules again, and we're going to create a NAT rule collection. So NAT is basically a way for you to say, allow you to, because when these private IPs, like anything, the RFs, they call them RFC 1918s, they're not internet routable. So anyone can use these IP addresses. So you need some way for people outside on the internet to access, resources in your network. And you need a way also for you to be able to access the internet without exposing these IP addresses, because companies don't know how to route to those. So we have what are called public IP addresses, which then can use what's called NAT to, NAT you outbound using ports, and then also inbound using ports. So you got source NAT and destination NAT. So this is going to be to allow RDP. And now usually in a production network, you're probably not going to, be allowing RDP through this way. You're probably going to be doing like bastions or VPN tunnels or client VPN, stuff like that. So I'm just going to put this as a, zero. We'll just do 200. And then the rule, it's going to be allow RDP, protocol, TCP, source address, any destination. This is going to be, so destination, that one, which is our outside IP address. The port for RDP is 3389. It's going to translate to the IP address of the, what was that? Test? Dev. Okay, so the dev VM, which would probably be 10.0.0.4. And then translated port is going to be 3389 for that one. So we're going to hit OK on that. And then now we should be able to access that virtual machine using RDP, using the outside IP address of the firewall. So I'm going to close out of this. I think it's still refreshing. All right, so it's in there. But I want to make sure that IP address is correct too. So if I go to the dev VM, it should be 10.0.1.4. Let me go back. Rules. Let's modify this. So 10.0.1.4. So let's save that. Oh, it's not going to let us. So let me give that a second, then we'll add that back in. Okay, so I got the route updated. I went in and changed the to a 10.0.1.4 now. So if I go and open up remote desktop now and paste in the IP of the firewall, I can then go admin. And this isn't ideal. Like, this is just for me because I need to get back into that VM. But I wanted to show you that it's actually going to route out to the internet now using this 22.91 address. So go ahead and grab the IP address. Yeah, typically you wouldn't really just say, hey, open up RDP from your firewall on the outside. Probably wouldn't be the best thing to do. So now this is going back to the dev VM. We can go open up our Internet Explorer again, and you see it's showing the old 129. If we refresh this page, it should change. So 22.32.22.91. So now we got traffic flowing through the security device that we have. And it doesn't have to be an Azure Firewall. Like, this could be a Cisco ASA in the cloud, or you could be Palo Alto, or you could be routing it back to a firewall that's on-prem if you have, like, say, Express Route set up of some sort, with, like, different tunneling and things like that going on back to your on-prem network if all your devices sit there. So that was just to show that there. And that's really it. So really now we have a full mesh of a network, basically, without having to create peering connections between the other. Well, I'm not going to say full mesh, but we basically have a hub and spoke set up to where it can then, communicate between the different networks without having to create peering connections between multiple VNets, because as you start to grow, they can become a problem, because now, say you have 5 different VNets and you have all of these VNets need to communicate, file servers or databases, things like that. This peer is going to have to be created 5 times, and then vice versa. If you got the other network, that's another 5 connections, and then so on and so forth. So there's just a lot of things that can kind of go wrong with having to do, and it's not scalable, I guess you could say. So now that we got that set up, I can show you one thing. So what I was mentioning before about, and again, we can still test. We can get to the other side. I wanted to mention about taking the time to try to actually put this in the code. So I'll give you one clue on how to do this a lot easier. So we know that we had a route table that we added to our dev subnet. So if we go in and we look for route table, we can see that, okay, this is how you create it. But if you see off to the right here, there's an import option. And this gives you the ability to import your existing configuration in. So we just need the resource ID. But what we do need to do is we need to actually create this block first. You don't even have to put anything in it. So you could just take this Azure RM route table. We're going to go to our dev, and I'm just going to slap this right here and there. I'm just going to call it Azure RM route table, blah, 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 example. Keep it the same. Then if you go back to your your resource group, or look for that route table, you're going to go into the properties here, and you're going to take this resource ID, because you can see here it says you need the resource ID to import this. So we're going to copy this. We're going to go back into the Visual Studio Code and we're going to do a terraform. Well, it actually gives you the command. Terraform import, okay. Import and then Azure RM underscore route table dot example. And then paste in our code here. And that's going to import this into the state configuration, but it doesn't create things out in the, you're still going to need to create the stuff here. So like, you're not going to be able to kind of, just automatically import or move stuff into your code or make anything out in the cloud until you actually get everything set up. Because if we go a plan now, it's going to be some stuff missing. So as you can see, we're missing, actually we go back, we need to add name, location, and resource group. So we got to have like the required stuff. So name, resource group, location. That's some easy stuff. We'll just say example, change this to main. Save those, and then let's just do another plan. So this should output all the stuff that's in our portal, and then that way we can then start just siphoning it all in one by one. And you want to get to the point where it says there's no configuration changes found, because you want it to basically sync up and match with what you got. So as you can see here, scroll down a little bit. So you see it's going to be replaced. So the name is, I have example. So we need to actually change this to RTB. So we changed that. Then our routes, we don't have any routes. We can add those, but I'm only going to add the one. You kind of get what I'm doing here. So I'm basically taking what's down here, because now if we see, if we go here and we run another plan, you could just keep running plans to kind of get everything smoothed out. So the next plan shouldn't show that the name's different. It just should show that we don't have the routes available. So sometimes this can get kind of slow depending on. Okay, so it's saying no changes, but we obviously know that there is some changes we need to add in, because this is going to force a replacement. We basically need to go in and make sure we add these two. Sometimes it's kind of weird, but yeah, you want to make sure you match all that up. And I'd say just kind of do that. You can see, as that's why I didn't want to kind of go through and do all the routes and stuff like that, because it's great for automation and not doing it repeatedly through the console. You can see you start to get through a lot of clickish type stuff. So that's really it. That completes the series basically of all the different other steps we did to complete and build this whole hub and spoke network. I mean, if you have any questions in regards to the, this setup, drop me a comment down below. I'll be sure to get back with you. You can also check out my blog. I'll post this on there as well. I got a couple different labs on various Azure, Terraform, networking related things. So, if you have any questions in regards to any of those, just let me know down below as well. I'll be sure to get back with you. Again, I'm going to try to start getting back into some more networking related things as well to try to push out. So, again, like and subscribe. I'll be pushing out new videos constantly. Again, thanks for tuning in, and I hope to see you next time.